Okay, so we have this into consideration. We have seen what are the various no what is the way in which the transportation model can be represented in the form of the matrix. So on your this side you will be having the sources and the name of the number of the sources like 1, 2, 3 till m are represented here. On this side there will be the on the upper side you will be writing the destinations. There are destinations 1, 2, 3 till destination n. So for a factory for a source 1, we have a supply that is written here, which is A1. For your source 2, we have the supply A2, and likewise for the source M, we have our supply as AM. Similarly, for the destination, for the destination 1, we have a demand that has been written here. Our demand is B1 for the uh, destination 1. For destination 2, we have our demand as B2, and likewise for destination N, we have our demand as Bn, right? So again, this C11 represents the unit cost of the product if it is transported from source 1 to destination 1. Similarly, here Cij represents the unit cost of the product, unit transportation cost of the product transported from source 1 to destination J. Similarly, here if we go, here CM3 denotes the no, unit cost of transportation if the product is transported from M source to third destination, right? So that we have already seen. Similarly, we have seen what is the meaning of X21. X21 is the unit, X21 is the units that are to be supplied from source 2 to destination 1. Similarly, here if we see C33 is nothing but the, X33 is nothing but the units to be supplied from source 3 to the destination 3, and likewise all we have already seen. That day I've told you the for a balanced transportation problem, we can initially we are going to see the balanced transportation problem. So for a balanced transportation problem, the addition of all this, that is your total supply, should be equal to the addition of all these demands, that is total demand. So here your supply should be equal to the demand, and that particular problem is called as the balanced transportation problem. Now in the in the form of numerical, when we are going to see the transportation problem, what will be given to us will be giving what are the number of sources with us, that will be given in the numerical, right? So the number of destinations that are also going to be given in the numerical, right? They are going to give us the supply across each of the source. So they will be giving us the values of A1, A2, A3, and no till AM, that is depending upon the number of sources. All this the supply values or the capacity values of each of these sources is no, that will be told to us. Again, they are going to give us the demand values also, the B1 value, B2 value, B3 till Bn value, depending upon the number of the destinations. The demand for each of the destination will be given to us, right? One more thing that they are going to give us is the values of this C11, C12, C13, likewise like Cij and CMN. All these values will be given to us. And what is the what we have to do is we have to find out what are the values of X11, X21, X31. All these X values we have to find out in such a manner that the total transportation cost is minimum. So what is the objective function here? The objective function is the minimization of the total transportation cost. And what are the constraints? Constraints are the supplies and the demands of each source and destination respectively. So I'm hoping that I've made clear what is actually a transportation problem, and with this data we are going to solve this transportation problem. So now let's try to represent this matrix by using some numerical values, right? So focus upon this now. um, So no, this is the matrix terminology what I've used here. So now transportation model consists of a matrix made up of the it will be made up of the squares, and these squares are called as the all these squares are called as the cells. So all this this particular part is the square, and all these squares are called as the cells. So your entire matrix is made up of these cells, and the matrix is also made up of the vertical columns that we have, and it is also made up of the horizontal rows, right? So this is how the matrix will look like. The cell is located and is designated by its row and column heading, right? So no, but firstly, if I have to locate this particular cell, so this cell will be called as this cell will be given a number as B1. Why B? Because firstly we are going to take the number or the name of a row, and then we are going to take the name or a number of your destination. Similarly, this particular cell will be called as this cell is designated as A4. This cell is designated as B2. This cell is designated as A3. This cell is designated as B3, and likewise, right? So now here you can see these are the here warehouses. These are this is the destination, and the plants that are given here, these are the source, right? So now here you can see all these 2, 3, 11, 4. These all are the unit cost of the transportation, right? ये सब हम लोग जब न्यूमेरिकल दिया जाएगा हमको, तो ये सब क्या होंगे, आपके यूनिट कॉस्ट होंगे, राइट? सो ऑल दिस 2, 3, 11, 4, 5, 6, 8, 7, all these values are the unit cost of the transportation. And we have to find out what are the units that we need to transport from plant A to all these warehouses, and plant B to all these warehouses, so that the transportation cost will be minimum. Again, you can see there is this particular plant A can supply 20 units, right? And plant B can supply 15 units, right? So again, you can see the warehouse, no, warehouse 1 has a demand of 10, warehouse 2 has a demand of 5, warehouse 3 has a demand of 12, and warehouse 4 has a demand of 8. So if we add the supply, total supply, so the total supply comes out to be 20 plus 15 is equal to 35, right? Similarly, the demand, the addition of the demand, so 10 plus 5, 15 plus 12 plus 8. So all this should come, this particular comes out to be 35. So this is now yeah, it is coming out to be 35. So this is 15 and this is 20. So 20 plus 15 will come out to be 35. So now what kind of problem this is? This is a balanced transportation problem in which the total supply is equal to the total demand, right? So I think you have understood, we have seen this particular matrix representation, right? So here we have put some numerical values and tried to understand how this will be look like. So this is how the numerical will be given to you, and what you have to find out is the values of all the units that can be supplied from plants from each of the plant to each of the warehouse, so that the total transportation cost will be minimum. So now to solve this transportation problem, there are very important 5 steps that we need to understand, and these 5 steps are firstly we'll have to make a transportation model. So make a transportation model, that means that many times it may so happen that the numerical or the question that comes is given in the statement format. So from statement format you'll have to convert it into the matrix format, and that is nothing but the step 1, which is titled as the make a transportation model. We have step 2 as finding out the basic feasible solution. So firstly, so to start with, we'll be finding out a basic feasible solution. So now we have understood initially, right? So what is a feasible solution? Feasible solution is a solution in where a feasible solution is actually the solution to the numerical as well. But we'll have to, but our aim is to find out the optimal solution, right? So feasible, there can be many feasible solutions, and these all feasible solutions have the potential to be an optimal solution. But initially, to start with, we are going to find out a basic feasible solution, And in step 3, if we are going to check whether this basic feasible solution is an optimal solution or not, that we are going to do with the help of this third step, in which we are going to perform the optimality test. The optimality test will be performed on the basic feasible solution. If the no the optimality test is passed, your basic feasible solution is only the optimal solution. If your optimality test is failing, so what we'll have to do is our basic feasible solution will have to convert it to no into the optimal solution. So that particular process is nothing but your step 4, in which we are going to convert the basic feasible solution into an optimal solution by iterating it, right? So we are going to perform some iterations, and that iterations will be helping us to move towards the optimal solution. So that comes in your step number 4. Right, now that we have now iterated towards an optimal solution, we are again going to check whether that no the answer on which we have arrived is really an optimal solution or not. That will be checked with the help of the check for optimality. If this check of for optimality is satisfied, then the obtained solution is an optimal solution, right? If it is not no if this check for optimality is not getting satisfied, what we are going to do, we are again going to repeat step number 4. That is, we are going to iterate towards an optimal solution, and likewise we are going to repeat your step number 4 and step number 5. So your step number 1, 2 and 3 will only get they will be done only once, right? After that, step number 4 and 5, depending upon what is no the optimal, depending upon what are the solutions that we are going to obtain, we'll have to decide whether to repeat these steps or not. And no that will be that will be giving us the final answer for that particular transportation model. Right, so I'm hoping that you have understood this step 5, all these steps. And let's see and apply this step for the numerical, and then we'll be understanding it. So basically we'll be dealing with only if this lecture is considered, we are going to deal with only these 2 steps. Let's understand these steps, because these are the initial steps, and very very important, and that are to be compulsorily done for every numerical, right? So let's take a numerical for understanding, and in that numerical we are going to apply all these 5 steps, right? So that particular numerical I've selected, and we'll be seeing all the 5 steps applied for a single numerical. And after getting the answer for that numerical, I think that the transportation model will be understood in a better fashion. So we have a numerical statement here, right? So there is a dairy farm. A dairy farm has 3 plants located in a state, and daily milk production at each plant is as follows. So the plant 1 has a capacity of production of 6 million liters. Plant 2 has a capacity of 1 million liter, and plant 3 has a capacity of 10 million liters, right? So we have 3 plants, plant 1, plant 2 and plant 3, with their supply capacity or the production capacities, right? So now they have given that each day the firm must fulfill the needs of its 4 destinations, that are the distribution centers, right? So milk requirement at each of these distribution center is given here. So the distribution center has the demand of 7 liter. The second distribution center has a demand of 5 million liter. The third distribution center has a demand of 3 million liters, and the fourth distribution center has a demand of 2 million liter. So these are all the distribution centers, and the demand across each has been given to us. So here we can see the supply limits or the production capacities of each of the plants, and here the demand of each of the distribution center has been given to us. Now nextly, they are giving us the cost of shipping. The cost of shipping 1 million liter of milk from each plant to each of the distribution center is given in the following table in 100 of rupees, right? So now this table is to be understood, right? So here we have a distribution center here. So there are 4 distribution centers, that is 1, 2, 3, and 4 that are given here. And we have 3 plants that are located. So all these plants are represented here, 1, 2, 3, right? So cost of shipping 1 million liter of milk from each plant to each distribution center is given in following table in hundreds of rupees, right? So what they are telling us that if I have to supply 1 million liter of milk from plant to 1 to distribution center 1, I will be requiring 200 rupees, right? So this is in hundreds of rupees. So I'll be requiring 200 rupees. Similarly, if I have to supply the milk from plant to 1 to distribution center 2, I will be requiring, for that particular plant, for each million liter, I will be requiring 300 rupees. Similarly, for each million liter from plant 1 to 3, I will be requiring 1100 rupees. For each million liter from plant 1 to destination distribution center 4, I'll be requiring 700 rupees, and likewise. So here if you see, if I take this random value as 15, so what this 15 tells me that if I have to supply 1 million liter of milk from plant number 3 to destination center 3, I will be requiring how much rupees? I will be requiring 1500 rupees, right? So if I have to, similarly, if I take this random value 1, so what this value tells me that if I have to supply 1 million liter of milk from plant 1 to plant for destination center 4, I will be requiring 100 rupees. So I think that you have understood this particular thing. Now they are telling us they are telling us that the dairy farm wishes to determine as to how much should be the shipment from which milk plant to which distribution center, so that the total cost of shipment is minimum. Determine the optimal transportation facility. So what they are asking us that how many liters should be transported from each of the plant to each of the destination center, so that the total cost of shipment is minimum. So that is our objective, right? So the total cost for shipment should be what? The total cost for the shipment should be minimum. So this is that we have to find out, right? So हमको क्या फाइंड आउट करना है कि हर एक प्लांट से हर एक डिस्ट्रीब्यूशन सेंटर पे कितना दूध भेजना चाहिए, and that will be that with that particular basis we will be getting the total cost of the transportation model. So we'll be dealing with step by step. All right. So here I have shown the step 1, that is make a transportation table. So now in this numerical data was given in the form of the statement, and few values were also given to us. So all those values will have to put in a proper format and make a transportation table or a transportation model. So now in which format we have to put? The previous format that we have seen, that is the matrix format that we have to put. So now here you can see I have written there are 3 plants. So I have 3 plants with me, right? After that I have distribution centers, and how many distribution centers are there? There are 4 distribution centers, right? So these 4 distribution centers are also given here. So now the supply of here I have represented the supply, and here I have represented the demand, right? So if you see in the numerical, it was given that plant 1 produces, or it is the production capacity is 6 million liters. So here you can see we have fetched the data from here. The plant 1 has 6 million liters capacity, 1 million liter capacity of plant 2, and 10 million liter capacity of plant 3. So I have we haven't taken will be representing in the form of million liters only. So here you can see the plant 1 has 6 million liter supply capacity, plant 2 has 1 million liter supply capacity, and plant 3 has 10 million liter of supply capacity, right? So all these supplies are given here, right? So the total of that happens to be 17, right? So total of this is 17 million liters can be supplied via 3 plants. Again, the demand of each destination center or each distribution center is given to us, right? So that was given us in the numerical itself. If you see the numerical, So we have been given the distribution center 1 has the demand of 7, 2 has the demand of 5, 3 has the demand of 3, and 4 has a demand of 2 million liters respectively. So here the digits 7532 are being taken here. So the demand for no for distribution centers 1, 2, 3, 4 is given here 7, 5, 3, and 2. Again, if we add this, 7 and 5 is equal to 12, 12 plus 3 is equal to 15, 15 plus 2 is equal to 17. So that means here supply is equal to the demand, and that means that this numerical is nothing but it is a balanced transportation problem.